welcome back to another thrilling episode. Today we're exploring one of the most intriguing questions of our time. Is there life on Mars? Buckle up, because the evidence is compelling, and it might just change everything we thought we knew about our neighboring planet. Mars has long captivated our imagination, appearing in countless science fiction stories as a potential second home. This fascination drives scientists and engineers to explore its mysteries, hoping to uncover signs of life. Stephen Hawking once said, "The idea that we are alone in the universe seems to me completely implausible and arrogant, considering the number of planets and stars that we know exist. It's extremely unlikely that we are the only form of evolved life." His words resonate as we delve into recent discoveries on Mars. NASA's Perseverance rover recently found a rock named Cheyava Falls, which suggests it may have hosted microbial life billions of years ago. Discovered on July 21st in Neretva Vallis, this finding could be a game changer. Why, you may ask? The case for life on Mars. Let's start with the main argument. If life once flourished on ancient Mars, it's entirely possible that it still exists today. Why? Because the conditions that would typically eradicate life, extreme radiation, harsh temperatures, and lack of water, may not have been enough to wipe out microbial life that could be hiding just beneath the surface. Scientists believe that some forms of life could survive for millions of years in the Martian subsurface, shielded from the unforgiving environment above. Astrobiology, the study of the origin, evolution, and distribution of life in the universe, places a significant emphasis on the search for life on Mars. The Mars 2020 mission, which includes the Perseverance rover, is dedicated to this quest. Jezero Crater, Perseverance's landing site, was chosen for its astrobiological potential. Billions of years ago, Jezero hosted a lake during a time when Mars was warm, wet, and more Earth-like. Water is essential for life as we know it, and the sedimentary rocks formed through aqueous activities in Jezero Crater could be excellent preservers of biological materials. Perseverance has also found evidence of igneous minerals in Jezero Crater, which are significant for life. On Earth, volcanic rocks provide energy-rich substrates for microbes to feed upon and inhabit. If ancient life existed in or around Jezero, fossilized remnants of those ancient organisms could still remain as morphological, elemental, or molecular biosignatures preserved in rock today. The rover is equipped with a suite of instruments designed to select and analyze astrobiologically interesting samples. So far, it has collected 23 core samples, which will eventually be returned to Earth for detailed analysis. This is crucial because while robotic tools can reveal much about potential habitability, analyzing physical samples in sophisticated Earth-based laboratories can't provide definitive evidence of past life. The study of astrobiology extends beyond Mars, utilizing space-based telescopes like James Webb to search for chemical signs of life on distant exoplanets and ground-based radio astronomy to listen for signals from intelligent species. While finding other Earth-like planets is a monumental challenge, starting from our search within our own solar system is a logical first step. With Mars and the moons of Jupiter known to host water, these locations are prime candidates for uncovering life. As we continue to explore these Martian rocks, we are making significant strides towards understanding the potential for life beyond Earth. The discoveries on Mars could hold the key to answering one of humanity's most profound questions. But this is certainly not the first exciting discovery we made about life on the Red Planet. Old evidence. Back in 1976, NASA's Viking mission made history as the first attempt to detect life on Mars. This ambitious mission consisted of two spacecraft, Viking 1 and Viking 2, each with an orbiter and a lander. The landers were equipped with a suite of scientific instruments designed to search for signs of life, making it the only mission to date with this explicit objective. Among the most notable experiments conducted was the label release (LR) experiment. The label release experiment was a groundbreaking attempt to detect microbial life in Martian soil. The procedure involved adding a drop of water containing radioactive nutrients to a soil sample from Mars. The idea was that if there were any microorganisms in the soil, they would metabolize the nutrients and release radioactive gas as a byproduct. Remarkably, the experiment did detect the release of gases, suggesting the presence of metabolic activity. However, the results were met with skepticism. Scientists debated whether the detected gases were indeed the result of biological processes or could be attributed to non-biological chemical reactions. To this day, the findings of the LR experiment have not been conclusively disproven, despite numerous attempts to replicate the results using different methods. This lingering uncertainty keeps the debate alive and underscores the importance of continuing our search for life on Mars. The Viking mission also included other experiments such as the gas chromatograph mass spectrometer (GCMS) and the pyrolytic release (PR) experiment. The GCMS aimed to identify organic compounds in the Martian soil by heating the samples and analyzing the gases released. Unfortunately, it did not detect any organic molecules, leading some to question the positive results of the LR experiment. The PR experiment attempted to capture carbon dioxide converted into organic matter by potential Martian microbes, but its results were inconclusive as well. Despite these mixed outcomes, the Viking mission's life detection experiments laid the groundwork for future exploration. They demonstrated the feasibility of conducting complex biological experiments on another planet and highlighted the need for more sophisticated techniques and instruments. The Viking mission's legacy continues to inspire and inform subsequent missions to Mars, such as the Mars Science Laboratory's Curiosity rover and the Mars 2020 Perseverance rover. The data from Viking remains a cornerstone in astrobiology, reminding us that the search for life is fraught with challenges but also ripe with the potential for groundbreaking discoveries. As we build upon the foundation set by Viking, each new mission brings us closer to understanding whether life ever existed on Mars, and by extension, our place in the universe. Perseverance's new discovery. Fast forward to today, and the Perseverance and Curiosity rovers are making groundbreaking discoveries that are reigniting our hopes of finding life on Mars. The Perseverance rover in particular has made an exciting find that could be a game changer. The rover has discovered an intriguing arrowhead-shaped rock named Cheyava Falls, which may hold signs of ancient life. The rock, discovered on July 21st as Perseverance explored the northern edge of Neretva Vallis, an ancient river valley, contains chemical signatures and structures that could have been formed by microbial life billions of years ago when Mars was much wetter. Perseverance's instruments detected organic compounds within the rock, precursors to the chemistry of life as we know it. Winding through the rock are veins of calcium sulfate, suggesting that water once flowed through it, an essential ingredient for life. Adding to the excitement, the rover also found dozens of millimeter-sized splotches, each surrounded by a black ring resembling leopard spots. These rings contain iron and phosphate, which on Earth are often the result of microbe-led chemical reactions. David Flannery, an astrobiologist from the Queensland University of Technology and a member of the Perseverance science team, noted that these spots were a big surprise, explaining that on Earth, such features in rocks are often associated with the fossilized record of microbes living in the subsurface. This sentiment was echoed by Morgan Capel, a scientist on the Perseverance team who pointed out that these three elements had never been seen together on Mars before. Cheyava Falls sits at the edge of a 400-meter-wide ancient river valley named Neretva Vallis. Scientists believe this channel was carved by water that once gushed into Jezero crater. In one scenario, mud containing organic compounds was deposited into the valley and later solidified into the Cheyava Falls rock. A subsequent episode of water flowing through the rock would have created the calcium sulfate veins and black ring spots observed today. However, the discovery isn't irrefutable evidence of ancient microbial life just yet. There is a possibility that the calcium sulfate entered the rock at uninhabitably high temperatures, perhaps during a volcanic event. The question remains whether non-biological chemical reactions could have resulted in the black ring spots seen by Perseverance. Despite the need for further analysis, the discovery has scientists buzzing with excitement. Nicola Fox, Associate Administrator of NASA's Science Mission Directorate, emphasized that the trip through the Neretva Vallis riverbed had paid off by revealing something entirely new, providing scientists with much to study. Ken Farley, Perseverance Project scientist at Caltech, added that they had thoroughly examined the rock using lasers, X-rays, and imaging it from every possible angle, concluding that scientifically, Perseverance had exhausted its investigative capabilities. These discoveries by Perseverance and Curiosity suggest that Mars may have had the right conditions for life and raise the exciting possibility that microbial life could still exist today, hidden just beneath the surface. As we examine these Martian rocks, we make significant strides towards answering one of humanity's most profound questions. Are we alone in the universe? Nature's resilience. The astonishing resilience of life on Earth offers a hint at the potential for life on Mars. Experiments have demonstrated that various forms of life, particularly extremophiles, can endure just beneath the Martian surface for extended periods. Researchers have simulated Martian conditions in laboratories and discovered that certain bacteria can survive for up to 280 million years if buried deep enough. This resilience hints at the potential for dormant life waiting to be discovered on the red planet. On Earth, extremophiles, organisms that thrive in extreme environments, provide compelling analogs for potential Martian life. For example, some bacteria and archaea live in the harsh conditions of the deep sea hydrothermal vents, acidic hot springs, and the cold, dry valleys of Antarctica. These environments share similarities with the extreme conditions found on Mars, suggesting that life could persist in Martian niches. One particularly interesting group of extremophiles is cyanobacteria. These microorganisms can endure extreme conditions by entering a dormant state, essentially pausing their biological functions until conditions become favorable again. This ability to hibernate could be a key survival strategy for potential Martian microbes, allowing them to withstand long periods of inhospitable conditions. Moreover, some microorganisms on Earth have evolved to metabolize rock and extract energy from inorganic compounds, a process known as chemolithotrophy. This metabolic versatility could enable Martian microbes to thrive in environments where traditional organic nutrients are scarce. The discovery of chemical signatures in Martian rocks that resemble those produced by terrestrial chemolithotrophs provides tantalizing hints of potential biosignatures. Perseverance and Curiosity's discoveries have already indicated the presence of water and organic molecules on Mars, essential ingredients for life. These findings suggest that Mars may have had a more hospitable past and that microbial life could have found refuge in subsurface environments. While the presence of extremophiles on Earth doesn't guarantee life on Mars, it certainly expands our understanding of the possible resilience and adaptability of life. The discovery of such resilient organisms on Earth provides a strong basis for hypothesizing that life, if it ever arose on Mars, could survive in similarly extreme conditions. Biological or non-biological origins. A crucial question that scientists are grappling with is whether the signs of life detected on Mars are biological or non-biological in origin. The distinction is critical because it determines whether we have found actual evidence of life or just a chemical process that mimics biological activity. On Earth, the presence of certain minerals and chemical compounds often points to biological processes. For instance, iron and phosphate minerals, which Perseverance has found on Mars, can be formed by microbial activity. However, they can also result from purely chemical reactions that do not involve life. This ambiguity necessitates a careful and thorough analysis of the Martian samples. One of the challenges in identifying biosignatures is that the harsh surface conditions of Mars can alter or destroy potential evidence of past life. Radiation from the sun, without the protection of a thick atmosphere, can break down organic molecules over time. This means that even if life once existed on Mars, finding unambiguous evidence of it is extremely difficult. To address this challenge, scientists are looking for complex organic molecules that are less likely to form through non-biological processes. For example, certain patterns of isotopic ratios in carbon compounds can indicate biological activity. Similarly, the presence of specific amino acids or lipids could suggest life, as these molecules are typically associated with living organisms. The Perseverance rover is equipped with advanced instruments to detect these potential biosignatures. The Sherlock instrument uses spectroscopic techniques to identify organic compounds and minerals that could be associated with life. Additionally, the Pixel, planetary instrument for X-ray lithochemistry tool, can analyze the elemental composition of rocks and soil at a microscopic scale, providing further clues about their formation. However, definitive proof of life on Mars will likely require more than just robotic exploration. This is where the Mars Sample Return mission comes into play. By bringing samples back to Earth, scientists can conduct detailed analyses in state-of-the-art laboratories using techniques that are too complex to perform on Mars. Mars Sample Return Mission. This is the goal of the Mars Sample Return Mission, a collaboration between NASA and the European Space Agency, ESA. This ambitious mission aims to collect samples from the Martian surface and return them to Earth by the early 2030s. The process begins with Perseverance, which is already hard at work collecting and caching samples. The rover's sample caching system carefully stores these samples in sealed tubes, ensuring they remain uncontaminated. Once a sufficient number of samples have been collected, the next phase of the mission will commence. The Mars Ascent Vehicle, MAV, will then launch the sample container into the orbit of Mars, where it will rendezvous with an ESA-provided Earth Return Orbiter. The Earth Return Orbiter will capture the sample container and begin the journey back to Earth. Upon arrival, the samples will be carefully analyzed in state-of-the-art laboratories, where scientists will look for signs of past or present life. This will involve a battery of tests, including chemical, isotopic, and microscopic analyses, to search for biosignatures and determine the origins of any organic molecules found. Bringing Martian samples back to Earth will provide unparalleled opportunities for scientific discovery. It will allow scientists to use the full suite of analytical techniques available on Earth, which far surpasses the capabilities of current Mars rovers. This comprehensive analysis will help us understand fundamental questions about the habitability of Mars and the potential for life beyond Earth. The Mars Sample Return Mission represents a significant step forward in our quest to understand Mars. But think about the prospect of sending humans to Mars. Having humans on Mars would revolutionize our ability to conduct experiments directly on the red planet rocks and soils. Geologists and chemists, in particular, would be invaluable for this task. Their expertise in analyzing rock formations and chemical compositions could lead to groundbreaking discoveries that are not possible with robotic missions alone. Imagine a geologist examining rock formations in real time, or a chemist conducting complex experiments right on the Martian surface. The ability to adapt and respond to findings instantaneously would significantly enhance the scientific return. Moreover, human presence on Mars would allow for more extensive and diverse sample collection. While rovers are limited by their programming and mobility, humans could explore a wider range of terrains and collect samples from more varied geological contexts. This hands-on approach would provide a more comprehensive understanding of the history of Mars and its potential to support life. So, if you are a chemist or a geologist, don't despair. You might be exactly what NASA and other space agencies need as a future astronaut. The skills you could bring could be crucial in unraveling the mysteries of Mars and potentially discovering life on another planet. The journey to Mars is not just about technology and engineering. It's also about the brilliant minds that will interpret the data and make sense of what we find. As we continue to advance our capabilities and knowledge, the dream of humans setting foot on Mars becomes more tangible. The combined efforts of robotic missions and human exploration will undoubtedly pave the way for unprecedented scientific breakthroughs. As we eagerly await the return of Martian samples, we stand on the brink of potentially groundbreaking discoveries. The search for life on Mars is more than just a scientific endeavor. It's a journey that challenges our understanding of life itself and our place in the cosmos. Thank you for joining us on this fascinating exploration of Mars and the possibility of life beyond Earth. Stay tuned to Insane Curiosity for more updates on this exciting journey. And don't forget to like, subscribe, and hit the bell icon to stay informed about the latest discoveries. Until next time, keep looking up and stay curious.